Welcome back. We are continuing with the problem solving in electrolytic cells. Let's get the questions. It's just taken from the past papers. Now this is the question. They say the sketch below shows a cell in the purification of copper. We know in the purification of copper we've got two types of electrodes there. One will be having impure copper, which is the anode. Another one will have in the pure copper, which is the cathode. Fortunately, they gave us the polarity of the battery. So the positive one, remember, is the anode, and the negative one is the cathode, meaning that A is the anode, B is the cathode. So if A is the anode, that's where we'll have the impure, if we analyze the cell, and B, that's where we are going to now purify copper. That's where is the cathode. Reduction will take place there. Now they say define the term electrolysis, coming from the previous one. Obviously we still remember as well, we say it's a process of converting electrical energy into chemical energy. So it's a process, this one. Now 9.2, getting better now. Which electrode, A or B, represent the impure copper? As we said, the impure copper is at the anode, which is the positive electrode according to this one. So the answer will be B. A 9.3. Now they are telling us to say which electrode, A or B, will increase in mass. Remember, the increase in mass happens where the reduction is taking place, and that is at the cathode, which is in this cell is the negative electrode. Therefore, we're looking at the cell, therefore negative electrode is B. Your answer will be B now for this one. Write down that's 9.4, write down the equation for the reaction that takes place at the cathode. The cathode, that's where reduction takes place, that's where copper will be formed, the solid. Therefore, the reaction that happening at the cathode will be where copper ions are reduced to form the layer of copper, purified copper there. Now we have got 9.5. 9.5, they say to us the color of the electrolyte remains unchanged. Remember, in these cells, together with the electroplating, we say the concentration of the solution remains the same. When the cell is in operation, is this statement true or false? Yes, I think we agree that the solution is this one. The statement is true. And then explain. Remember, we said it's because the rate of oxidation at the anode, if you want to be explicit, equal to the rate of reduction at the cathode. That's the best one. So you can just say the rate of oxidation equals to the rate of reduction. That's also enough for the answer if you don't want to be explicit. Now 9.6, they're telling us to say the two electrodes A and B are now replaced with carbon. Now we are no longer going to purify. Now we'll be going to the electrolysis of copper chloride. So once we change to carbon, which are inert electrodes, then now we go into electrolysis of copper chloride. So no problem. Now write down two reasons why carbon is used as electrode. We already said it's a solid, one, Yes, electrodes are normally solids. And the second one will be carbon electrodes are used because they are not reactive. They are inert electrode, non-reactive electrodes. You can also mention the question of, say, they are good conductors of electricity. They can conduct electricity here, conductors of electricity. Besides being solid, yes, electricity. It's just same as the platinum in the galvanic cells. Yes, the next question, they're saying to us, at which electrode, A or B, will chlorine form when the cell is in operation? Remember, we know from this previous representation that chlorine is formed at the anode. Then we are looking for the anode in the two cells. So that's where oxidation is taking place. Anode is the positive electrode. Therefore, chlorine will be formed at electrode A. It will be A. They say write down the half reaction now to show the formation of chlorine. Therefore, chlorine is formed when from the table. We check from the table, you'll find that now chlorine gas is formed when the reverse reaction is taking place, which is the oxidation. Therefore, then chlorine ions are attracted to the anode, which is a positive electrode, as a result forming chlorine gas and 2 moles of electrons. The last one, which is number 9.8, they say to us, state whether the concentration of the electrolyte will increase, decrease, or remains the same. Remember, in this case now, we no longer, the concentration, the ions in the electrolytes now are taking part. They are either undergoing oxidation or reduction. Therefore, the concentration of the electrolyte now will no longer remain the same, but will decrease. Thank you. Therefore, it means that now the answer, correct one there, will be decrease because the ions in the electrolyte are taking part. So that's 15 marks for us. Hopefully we are getting better, and thanks a lot. Bye for now.